and welcome to TopSolid 7. In this video, we're going to take a deeper look into the timing screw function. I thought it'd be really cool if I showed you just how easy it is to build a screw like this from scratch. But to begin with, I'm going to start by showing you the end result, and the best way to do this is to watch a simulation. So in this case, I'm going to go to simulation, hit play, and I'm going to use my plus and minus arrow keys to speed this up. You can see my bottle is moving at a fixed speed right now. So it's moving down this conveyor, the screw is moving it forward, and once we get about halfway through, I'm going to speed it up. Pretty cool, isn't it? Now, how do we get here? That's the trick, isn't it? Most softwares you're going to spend hours and hours, if not days and days, and in some applications probably weeks of work just to build a simple screw like this. In TopSolid, I'm going to show you that you can get this done literally in minutes. And that's the battle, isn't it? To take and streamline your design process to the point where it takes you next to nothing to design your parts to maximize your profitability. Let's have a look how it all starts. I'm going to start by closing this and show you the bottle. In this case, I just have this simple little bottle. Now, this bottle was designed in TopSolid. No big deal. Bottle's 5 inches tall, looks like this. It can be any shape you want it to be. It doesn't really matter to us. The bottle could be imported as well. It could be a 3D digitized copy of your customer's bottle. However, the only requirement is that the bottle must be at least a solid model. Now, if it comes in as a surface, no big deal. TopSolid has great tools to help you fix that model and turn it into a proper solid. But for now, let's just say we need a solid model of the bottle. Good. Next, what we need is a solid model of the OD of the screw. So here, I have a simple OD of the screw. It's 24 inches long, 3 inches in diameter. Perfect. I have a frame here as well, and this frame is going to be used for positioning. Now, if you're not a TopSolid user already, what I did here was I created a frame and then right-clicked on it and published that frame. By publishing the frame, I was able to use this frame to position within the assembly document, which I'm going to show in the very next step. So here, I'm going to start by going into my assemblies folder right here. Why not? And I'm going to say I'd like to build a new assembly. I'm going to choose my screw start command. I'll go ahead and validate. Now, this is going to be my, timing screw. Perfect. Now, I'm going to begin by explaining what we have here. Now, I started a template that already had some frames defined, and this is just to win some time because maybe I design a lot of timing screws, and I know I always have to start with this same general configuration. So using a template, again, helps me minimize the amount of time it takes. From here, what I'm going to do is set up some things. This first frame, think of it as your absolute frame. This is the absolute zero of the document. My part is traveling in my x positive direction to the right along that direction. This is where my bottle is going to be. So I want my bottle to be timed at precisely 1.607 inches from my zero. Okay? And I want my screw, if you will, to also be timed precisely 1.763 inches. Double click, double click. I don't need this one, so I can hide it if we want. If you're going to add a second screw or a third screw or a fourth screw, you would just keep defining these locations. From here, I'm going to include my screw. So this is, again, just the simple cylinder. First thing I need to do with this is position it properly on the frame. So I'm going to edit my positioning. Again, if you're a TopSolid user, you know that the first part you drag and drop into an assembly comes in fixed, so you got to right click and unfix it. After that, we can use frame on frame positioning. Notice that publishing I talked about before. Pop it right on that frame. Cool. Done. From here now, I'm going to go ahead and add my bottle. Again, I'm going to use frame on frame positioning, grab that frame to that frame. Perfect. Now I'm going to look straight down at this, make sure everything is set up the way I want. I want this to start roughly here, and it's going to, again, move in the x positive direction. Now's a good time to hit save. Now, I could take and just use the same timing screw scenario that I've already created ahead of time. But I'm not going to do that. I'm going to show you instead how I built this information, and more importantly, what this information means. So here across the top in X, Y, and Z, this is the position of the bottle, relative to my frame. So I'm starting, remember, from my absolute frame, 1.607 inches off the part here, or off my screw, which is great. And I'm starting at minus 360 degrees revolution. So I want my screw surface to start all the way back here, which is fantastic. Next, I am describing moving forward in X, the next position of the part that I want to make sure I have a section for, and its location in time or degrees around the part, and so forth, so on. Okay, so this represents having the parts exactly, I forget, I think it's 1.6 something inches apart from each other, up to 12 inches, and then we increase the spacing to 4 inches right from there. Now, how did I get all this information into this table? Let's have a look. I'm going to start by closing that, and then I'm going to start by beginning a new Excel document. And apologize, that opened up on my other screen here. And I'm going to start a new Excel document. Now here, I want you to think as A, B, C as X, Y, Z, and then our different fields from, again, that scenario document. So what I'm going to start with here is just setting a couple basic things. I want minus 1.607, 0 in Y, 0 in Z, minus 360. Okay, this is the timing relative to the rotation axis of X. 0 rotation in Y, 0 in Z. F1 is just a random name I'm giving because I'm using one bottle. Now I could move more than one bottle, but F1 says for the first bottle I select, use this line of code. Then these next two zeros are for controlling what we call the density of the sections that we create, but I'm using a different file to control those, so 0 is good enough for me. So this is the beginning, and now I'm going to use Excel to kind of help me out. And here's how we're going to use Excel. If you've used Excel before, you know there's all sorts of magic tricks that exist in Excel. So for example, I can say that this is equal to this plus the spacing distance that I want. I want 1.237. Okay? That's the radius of, or pardon me, the diameter of the part, I think, of the bottle. Now from here I'm going to go 0, 0, 0, because by the time I get to minus 0.37, I want to have done one full revolution in the positive direction. And again, 0, 0, F1 again, 0, 0. Finally, I'm going to repeat this. Now watch. Excel is pretty handy. I can take and bring this all the way down here and let it keep doing the math for me because I want to maintain this spacing, right? And I want to do that to 12, which is great. Here what I want to do now is say this is equal to this, because this is where I increase it, right, to plus 4. And I'm going to do this until we get up to, I think, 28. Yep, 32 is too much. And then from here, we're just going to keep the values going. Now watch. I'm going to say this is, this is 0, 0, 360, 0, 0, F1. And I'll show you another magic trick here in Excel really quick. So now I want to have, we'll do one more. This equals this plus 360, right? And then 0, F1, oops, got ahead of myself. 0, F1, 0, 0. And now finally, let's use those magic tricks, shall we? So if I go to here, and I start dragging these down, boom, we're done. Except, look at what it did to all my F1s. It added them, because that's what Excel does. I needed to do this not as F1, F2, but just as a control copy. Perfect. But at the end of the day, I have all the data now as I need it. Now, I'm going to minimize this off to the other screen, and we're going to go back to TopSolid. Because now in TopSolid, what I'm going to do is build that scenario file. Now, when I build a scenario file, because it's not something I do every time, I have to go to my documents, go here and choose timing screw scenario. And I'm going to call this cool screw command. Why not? And here I have to start by choosing my units of measure. So I want this to be inch, I want this to be inch, this to be inch, this to be degrees, degrees, and degrees. Finally, I'm going to bring back my Excel file, and I'm going to copy everything here. Control C. I'm going to come back to here, right click, and paste. And now I've just propagated all of those fields into TopSolid. Now I got to be careful down here because I don't actually need this line. Good. And let's save. And guess what? We've now done all the hard work. Let me show you what I mean. I'm going to go back to my timing screw command, And now I'm going to go to timing screw, hit my timing screw command here, and I'm going to describe everything. My geometry frame, pardon me, is this. The geometry in question, shape, is this. My master screw is that. And I want to use my cool screw command. Lastly, I want it to trim the rough right away for me. And here we go. So now what I'm doing is I'm waiting for TopSolid to do the heavy lifting for me. This is where it's taking the scenario file plus the shapes I've created here, and it's automatically going to create this timing screw for me. And I'm not going to pause my video because I want you to see in real time just how fast and efficient this function really is. And then we're going to go make some changes to it as well, just to show you the parametric nature of the software. So there you go. Like that, timing screw is done. And just like you saw at the beginning of this video, if I hit play, this works the exact same way. I can hit play, watch this thing go down, speed up, slow down, doesn't matter. Boom, done. Now, I'm going to hit save once. Because what's important here too is sometimes as you're playing with your design, you maybe are told that, you know what, the rules have changed for this specific screw. Maybe once we get down to here, we need the bottle not only to speed up, but to tilt forward 45 degrees. Maybe it's just for 2 revolutions, then it's back to vertical. Let's take a look at how you would fix that. Let's go to cool screw command, our scenario file. I'm going to say once we get to 16 inches, that's after 1 full revolution at the 4-inch spacing, I want to rotate about Y 45 degrees. And I want to stay rotated through the 20-inch point at 45 and then come back to 0. That's it. Hit save. Now all we have to do, we go back to timing screw. And now all I need to do is regenerate everything. And the way you do that is to hit Control R on your keyboard. And now TopSolid again is going to reread that scenario file. It's going to re-update the screw design, and because of this, re-update the solid model. And again, this is just showing you some of the really cool but yet ridiculously powerful features of TopSolid 7. And just to point this out, all the other softwares on the market, they're still figuring out how to make a simple helix. That's the difference. Here we go. We are almost done. This one's going to calculate a little bit longer because of, again, tilting the bottle, but you'll see in a sec the result. And there we go. So notice the screw is now changed. Let's watch the simulation. And this is just wicked cool. So I'm going to put this on the side like this so you can see it. We'll speed this up a little bit. So remember, we're going to do 1 revolution at the 4-inch spacing, and that bottle is going to tilt forward. Watch. Boink. How cool is that? And now let's tilt it back. And we're done. Hope you found this video interesting. Check back soon for more.